Hi viewers, good morning everyone. Welcome to செவிவழி கல்வி சேனல். நாம் இன்னைக்கு பார்க்க போற கான்செப்ட் என்னன்னு பார்த்தீங்க அப்படின்னா டிஜிட்டல் லாஜிக் டிசைன்ங்கிற சப்ஜெக்ட்ல HCL ப்ரோக்ராமிங் எப்படி பண்ணலாம் அப்படிங்கிறத பற்றி இன்னைக்கு பார்க்க போறோம். ஸோ அதை இன்டெப்த்தாக பார்க்கறதுக்கு முன்னாடி we have to know what is VHDL and what is Verilog. So both are primary hardware description language. Simply we know HDL refers or abbreviation of HDL is hardware description language. Verilog and VHDL are both are two primary hardware description languages, and simply we can say HDLs. So all engineers and designers use to model and simulate and synthesize the digital systems. So these languages are very crucial for developing integrated circuits. That is, ICs manufacturing and developing concepts can be implemented with the help of this hardware description language programming. And also the field programmable gate array FPGAs also developed with the help of this two languages and other digital hardware also. So this is the what is VHDL and Verilog concept. So next we move to what is mean by VHDL. So the abbreviation of VHDL is nothing but very high speed integrated circuit hardware description language. So it is also the language that describes the behavior of electronic circuit, most commonly digital circuits. So we prefer only digital circuit for coding using this VHDL programming language. So VHDL is defined with the help of this IEEE standards. So only the digital circuits can be developing with the help of this coding of VHDL programming. So next Verilog. So Verilog also one kind of standardized IEEE 1364. It is also a hardware description language mainly used to model electronic systems. It is commonly used in design and verification of digital circuits at the register transfer level of abstraction. So this is the main difference between VHDL and Verilog. So next we move to comparison of HDLs, that is VHDL and Verilog. So we know the ADA like verbose syntax, lots of redundancy, and Verilog coding is similar to C program. So ADA is one kind of simulation program. So the VHDL syntax are mainly depends on this concept, and Verilog programming concept similar to C programming. And VHDL extensive types and simulation engine. So here in Verilog, built-in types and logic representations are present in this Verilog programming. And design is composed of entities, each of which can have multiple architectures. So whenever you go for VHDL programming, always we have to use entities in the program. At the same time, we have to mention the multiple architectures and use different library in the format of IEEEs, and what are the requirement of library files for the particular program. Everything should be included in this VHDL program. But when you go for Verilog program, the design is composed of modules. That means just one implementation. So with the help of Verilog programming, we just start our program with module and end our program with end module. But in VHDL, we have to start with the entity and end with the entity. So next, in VHDL, gate level programming, data flow modeling, and behavioral modeling also synthesizable subset. In Verilog also gate level, data flow, and behavior modeling synthesizable subset possible. That means we can able to write a program in three category of modeling method: gate level modeling, behavioral level modeling, and data flow modeling. Both VHDL and Verilog support this three category of modeling method to design any particular concept in combinational circuit or sequential circuit. At last point, harder to learn and use. That means the VHDL is somewhat difficult, but Verilog coding is easy compared to VHDL program. So these are the comparison between Verilog and VHDL. So next we move to Verilog code. So in Verilog code, what are the different category of flow methods are available? That difference can be explained here. So first method, we just take structural modeling method. So in structural modeling method, we have to take the program name. So before going to start the program, we have to assign the module for Verilog. So module, and the module name is half adder structural. So here I am performing half adder designing. So for that I just take half adder as my name of the module, and which is in the form of structural modeling method. So I just mentioned structural. In case if you want to mention the structural or behavioral or data flow, you just mention. Otherwise, if you are a programming knowledge person, you no need to mention these and all. So whenever we mention these kind of structural or data flow or behavioral in the program itself, so any person once see the program, so based on this they can easily understand, oh, this is a structural modeling method, or this is data flow modeling program, this is behavioral model method. Likewise, they can easily understand. So the module is mentioned here, and the name of the module is defined as half adder, and which is in the form of structural modeling method. So everything is mentioned here. After that, we just open the parenthesis, and input A, input B are taken. So before going to see this, you have to know the logic of this half adder. So for half adder, we need two inputs A and B, and two outputs are sum and carry. So which is denoted in the form of whether it may be input or output. So input are defined in the variable A and B, and outputs are sum and carry. So we just mentioned input A and input B, output sum or S. Similarly, output carry or C. So these are the variables we have to assign in the module. After that, what operation we want to perform? That means whenever we design this half adder, so initially we have to identify the two inputs or a number of inputs required for the particular circuit. So for half adder, we need two inputs and two outputs. One inputs are defined as A and B, outputs are sum and carry. So these are represented here. After that, we have to draw the truth table. So once the truth table is over, we have to draw the K map. So from this K map, we can able to mapping, and finally we can find the expression for the particular parameter. That means it may be sum or carry. So first we determine the KMF for sum, and we determine the KMF for carry. So after that we found the expression for the sum is A XOR B. So here we just mention XOR gate, XOR operation of sum, comma, A, comma, B. That means sum is our output. That should be taken first. And after that, two input variables A and B. So what operation we required in the circuit diagram, logic diagram, XOR operation. So the XOR sum, comma, A, comma, B. That is mentioned here. And one more output is there, that is carry. The carry output will be A and B. So at the time, AND gate variable can be represented, and AND of C comma A comma B. So in case if you want to mention instead of S, instead of C, sum and carry directly, you can write like that also. There is no problem. So this is structural level modeling method. The same concept can be applied in data flow representation. So what is the difference between this two category of method means, just instead of this gate, here we are going to use the operator. So here A and B. So for that we just assign carry, assign C equal to A and B. And symbol is used for performing the AND operation. Similarly, XOR operation, we just mention this cap symbol. So assign sum equal to A cap of B. So this is only the difference between the structural modeling method and data flow modeling method. So instead of gate, we are representing only the operator here in data flow method. So when you go for behavioral model, again the same module half adder behavior. Here also you can represent module half adder data flow instead of structural level. So what level of modeling method you are using in this programming, that variable can be assigned here for our understanding. So here the module half order underscore behavioral. So in behavioral model method, we are writing this half order programming using Verilog. So input A, input B, output sum and output carry. So for this we assign the variable like this. So here the sum is equal to, here we have to mention always at start. So the sum is equal to A cap of B and C equal to A and B. So at the end of this program you have to end the module. So everything is over. Here we can differentiate the three category of modeling method, whether it may be a structural modeling or data flow modeling or behavioral modeling. So likewise, we can use a variety of program. That is, we can able to design a combination circuit or sequential circuit based on this structural modeling method or data flow modeling method or behavioral modeling method. I hope everyone understand this difference between these category of modeling method using Verilog. So all of you see this video and subscribe my channel. If you have any queries, you can ask me. And கண்டிப்பா எல்லாரும் என்னோட சேனலை சப்ஸ்கிரைப் பண்ணுங்க, லைக் பண்ணுங்க, பெல் பட்டன் அழுத்துங்க. Thank you all.